Hello, so this is the next subtopic we are doing. Probably this is the fifth video recording that I'm doing. The next topic is Mayerhof'S analysis. It's a very small topic. Just like Terzaghi's analysis, this is another way to analyze the bearing capacity failure or failure in the foundation due to insufficient bearing capacity. Okay, now this particular theory was proposed in 1951 by Mayerhof. Okay, and this is applied for rough, shallow and deep foundations. So if we try to recollect Terzaghi's analysis, it was not for deep foundations. Okay, now assuming that logarithmic failure surface ends at the ground surface. Okay, so if you realize, if you can see, the curved surfaces are reaching near the ground level. Alright, this was not happening in case of Terzaghi's analysis. Terzaghi's analysis, the surface would end till the base of the foundation. Okay, so there are some very small differences between the two. Okay, so assuming that the logarithmic failure surface ends at the ground surface, and as such, he took into account the resistance offered by soil and surface of the footing above the base level of the foundation. Right? Now let's try to analyze. Now if you look at this diagram, whatever is on this side is Mayerhof's theory, what is on other side is Terzaghi's theory, which we have already covered. Okay, so more or less same. Only thing what is happening, the failure surfaces, logarithmic surfaces are going way much above the foundation level. So where is the foundation level? This dotted line is a foundation level. Okay, now ABD, this triangular wedge, is a elastic triangular wedge. It's under elastic equilibrium. What is elastic equilibrium? Elastic equilibrium is this particular wedge of soil will be behaving as if it is monolithic with the foundation. It will be moving only vertically downward. There will be no laterally outward movement of this particular wedge. Alright? Then B, D, E. Can you see this? This entire portion is the radial shear zone, with DE being an arc of logarithmic spiral. So this, if you see this particular curve DE, it starts with very minor radius. The radius here is much smaller as compared to the radius here. That's a logarithmic spiral. The equation will be logarithmic for this particular curve. Okay, so now DE is an arc of logarithmic spiral, and BEFG okay, is a mixed shear zone in which the shear varies between limits of radial and plane shear depending on the depth and roughness of foundation. Okay, so based on how deep your foundation is laid, then entire this curvature in some places might even look like as if it's a linear curve. I mean, it's a line. Okay, so that depends on how deep is your foundation, what is the roughness of the foundation. Alright, BD failure surface is considered. Where is BD? This is BD. Okay, and its inclination is considered this angle. Okay, ABD. This angle is considered to be 45 plus phi by 2, where phi is the angle of friction. Okay, so this angle ABD will be 45 plus phi by 2 with the horizontal. Okay, which is followed by logarithmic spiral which extends near the ground surface. Okay, now if you look here, you have this P naught and S naught. If you see, the direction of P naught is normal to BF and direction of S naught is along BF. So what are these P naught and S naught? P naught will be the normal stress and S naught is the tangential stress. In other words, we also call it shear stress, which is acting on BF. In this particular case, it is acting on BF. Alright, so P naught and S naught are normal and tangential stresses. The superposition method is used to determine contribution of cohesion C, P naught, phi and gamma on ultimate bearing capacity, which we denote as Q suffix F. Okay. Following are ultimate bearing capacity equations considering shape, depth and inclination factor. Now the parent equation is this. Okay. Parent equation is just this is supposed to be QF. Okay. The parent equation is this. For particular cases, in case of vertical load, this equation gets modified into this, and the same equation for inclined load is modified slightly. Now, what is the modification in this case? You will, when the loads are vertical, you won't find IC and I gamma. Okay, when the loads are inclined, you are not finding SC. So there will be slight changes. What is NC, NQ, and gamma? These are bearing capacity factors. Now this NC, NQ, and gamma, the equations governing are also given by Mayerhof. Okay, and at the end of the presentation, we will see that they are tabulated for various values of phi. You can clearly see their function of phi. Phi changes, the value of these factors will change. Correct? Everything entirely they are dependent on only phi. So there is a tabular column wherein you will have one column of phi and then corresponding NC, NQ and gamma factors. Okay. Now coming to this SC, IC and DC factors. Now what is SC, IC, DC? SC, SQ, S gamma, these are shape factors. IQ, IC, I gamma are inclination factors. Okay. For the load inclined at an angle 0 to vertical. Okay, so this is not 0, this is theta to vertical, or in your BC Punya the angle will be alpha to vertical. Okay, then DQ, DC, D gamma are depth factors. Okay, gamma dash is effective unit weight of soil above the base level of foundation. Gamma is the effective unit weight of soil below the foundation base. D is the depth of foundation. Kp is given as 10 squared 45 plus 5 by 2. What is this Kp? It is passive pressure coefficient. Okay. Now whenever you are going to input this value phi, you are not going to put any sign. Okay, it's just the value that is going to come, no positive, negative. Is the width of footing. Okay, and D will be the depth of footing. D is the depth of footing. Alright. The shape factors, these are given by Mayerhof. Various equations are mentioned here. Okay. Alpha is the inclination of the load, inclination angle of resultant measured from vertical axis. Kp is the passive pressure coefficient. Okay. Rest of things I have already explained before. Okay. The equation proposed by Mayerhof to calculate phi for plane strain in terms of phi of triaxial will be given as 1.1 minus 0.1 b by n into phi triaxial. Right? And this is the final tabular column wherein Mayerhof'S bearing capacity factors are tabulated for various values of phi. In case the value of phi which is given to you maybe in your problem is somewhere in between, then you need to interpolate. Okay. Now coming to the end, I want you all to answer these two questions. Compare the bearing capacity factors proposed by Terzaghi and Mayerhof and what is Kp. These two questions I want you all to answer. Okay, these are the references. Okay, the main presentation more or less I have taken from this presentation which is available on SlideShare. Okay, and a lot of content I have taken from NPTEL and BC Punya. Alright, take care. Stay at home, don't roam around. I know you all will be losing your patience now, but still somehow you will have to bear it. Okay, till government announces us to be in green zone, don't move out. Alright, stay at home, study well, You all are not posting any problems, so I'm just assuming that you all are understanding everything. Alright. Also, if you have any question papers and you want any answers, so far I've been only covering theory, so anything related to theory questions. Once I start solving problems, maybe I can post problems that have come in Goa University question papers. Alright, so if you have anything, you can text it to me on my phone number. Your class representative will have it. Yes, thank you. Stay safe.